right, let's get this one rolling. Thank you guys for returning here after lunch to see more of a talk on automating Asterisk in Kubernetes. In this session, I'm going to talk about operators. So this is another approach to automation that tightly integrates with the Kubernetes API. We're going to have here a overview of what's going on, and then I'm going to do a demo, and then I'm going to follow up with some of the lessons learned here and talk about when this technology is appropriate to use. And I've also got, for the demo, I've got an article I've put together that will show you how to set up the development environment yourself and run the code I've got here and potentially lead you to creating your own operator. So that's what we're going to do. And let's first address the question of what is an operator? And essentially, an operator is a Kubernetes application that manages other Kubernetes applications. So you can program into it operational knowledge that you have. I'd also add to this that an operator manages other applications in Kubernetes, but it also integrates tightly with the Kubernetes API. So why would you use these in the first place? And essentially, it's that you can take your business requirements for the operational lifecycle and you can embed those into this application which manages other applications. And that person that knows that business logic, it's you. So this is why you care about it, is that nobody can quite know that institutional knowledge like you do. So for the demo portion here, I'm going to be using the Operator-SDK. This is some hot off-the-press software from Red Hat, and it's crazy early. This is still pre-alpha software, but I have to say that my user experience with it so far has been super positive. It does a lot of the dirty work for you, so that you can just get using it, and it's going to have some built-ins for querying the API, looking at some of the resources we use that are sort of the lingua franca here. And I would say it's definitely worth a try, and it's only going to get better from here. And like any framework that you use, it tries to give you some kind of standard footing to stand on. So not a bad idea to give it a whirl. Something kind of key here, in fact, extremely key here, is the idea of a CRD, which is a custom resource definition. Sometimes when you hear people talk about Kubernetes CRDs, they talk about them in a pretty highfalutin manner, and I think that's entirely inappropriate for them. So you'll often hear them defined as a way to extend the Kubernetes API, and they do that for you. But that sounds like such a big idea and such a intense way to put it, that I'm extending the Kubernetes API, that I think it's an inappropriate way to define them, even though they do that technically. What they really do is they give you a way to store some metadata that you can query from the Kubernetes API. So we start with a CRD, the custom resource definition itself, and then inside of that definition, we store objects that we call custom resources. So if you're sort of to diagram out how your application is going to interact with these portions, you've got your CRD itself on the left, the box with the corner cut off, and that custom resource definition is fruit. In reality, it'll probably be a longer name. It'll be like fruit.organicitems.mycompany.org or something like that, right? And we're going to create custom resources under it, objects, and they're simply going to be a standard format that we know from how the CRD was set up. So we can say, all right, this object is a lemon. It's got a sour flavor. It's yellow in color. And you can go and create n number of those as you want. And it gives you a spot where you can store them that your application is going to be able to get them through that Kubernetes API. Chances are, if you're building one of these, you're already interacting with that API pretty heavily. So it gives you a spot to store that information. And this is kind of the lingua franca of operators. So if you have a number of operators, they're all going to be stored in a spot where other operators can also access these. So what does your application flow look like when you're creating an operator? And I essentially see it as 3 different steps here. It's going to observe, and by default, and the usual way that an operator works is it's going to watch what's happening with your CRDs. So it's going to say, okay, I know to look at the fruit CRD, and depending on what objects I see there, I'm going to do something with them. So that's where we come into the analyze step. So it says, okay, I've seen this new custom resource, and I'm going to analyze it. What's different about this? What's changed? And then it's going to perform an action on them. So it's going to act on what those are. So if we put this into the context of Asterisk, for example, we're going to start a watch. We're going to observe that custom resource, and we're going to say, okay, did anything change? Okay, it did. And then we'll make an analysis. What does Asterisk look like right now? How is it configured? Is it behaving the way that I want to? And then depending on what you've analyzed there, you'll act upon it and you'll change the behaviors there. So this is what we're going to demonstrate is this particular application flow. And we start in the same way. We're going to observe. We're going to observe a custom resource. And it starts, and that resource doesn't exist. So it sits there with a watch. Once it finds that there is a custom resource available, it's going to analyze it. And it's going to have a little bit of metadata that's stored there that says, how many Asterisk instances do I want? So we'll say, oh, I found 2. So what it's going to do is go and spin up 2 Asterisk instances, and then it's going to automatically create trunks between each of those instances. So it'll go to one, and it'll say create a trunk to the other, and then vice versa. It'll go to the second and create a SIP trunk for the first. It does that using a push configuration, so it's just ARI. And with sorcery, you can basically push in anything that Asterisk knows about, right? So in this case, it'll be PJ SIP configurations that it pushes up there for us. And then that's a custom resource will change. So we started with 2 Asterisk instances, and we're going to change it so that we say, hey, guess what? I want a 3rd Asterisk instance. So it's going to spin up that 3rd Asterisk instance, and then it's going to go and do the same cycle where it goes and creates a SIP trunk for each one to the next and to the next. And now it's time to show it to you guys in action. Leif's setup is a lot more polished and visual. This one is a lot more at the command line. So Leif was using OpenShift proper. So OpenShift is a distribution of Kubernetes, and it's opinionated. And it provides a lot of useful tools for you. Like if you're installing Linux, you would expect it to have a text editor, for example, and most distributions are going to make sure you have VI, for example. And if they have Emacs by default, it's clearly a flawed operating system. Just kidding. So similar kind of thing with OpenShift. Like, it has a dashboard that looks good and provides you with a lot of functionality that's useful right out of the box. In this case, I'm using just a vanilla upstream Kubernetes. So it's really raw. It's like using Linux from scratch. It's not that great, but it's for production purposes. It's great in terms of trying to mock something up or demonstrate something. It's very unopinionated, and it's fairly loose in terms of security. So for demoing something, makes it real easy. So let's go ahead and move to the demo after I've... All right. So one of the first things that I'm going to do is I'm going to say kubectl get CRTs. So these are the CRTs that I have set up on my system. And I have one that's called asterisks.voip.example.com. And you can create resources under that. So if I say kubectl get my asterisk CRTs, none are found right now. So this is the way that I'm going to begin the operator. Is like I diagrammed is we'll start the operator, and it's not going to see any custom resources yet. So let's...
Why don't you do a -o YAML on the end just to see what the CRD looks like itself?
Yeah, totally. Or actually...
Just hit up and hit -o.
Yeah, let's do
just
that.
-o YAML, do it right.
So this is the definition. This is basically the house under which the objects live. And basically what I'm saying is the kind of this object is a custom resource definition. Its name is asterisks.voip.example.com. Why is it asterisks with an S? Is because by default you name these with a plural, which it just so happens that we have an awkward one to put a plural after. And it lives in this particular group, which is voip.example.com. And why would it be that group? Is, well, let's say my company is example.com. We may have more than one VoIP CRD. So this is to like plan as if you were going to also have, say, a ilio voip.example.com, etc. And really, that's really the only constraints on this particular CRD. It's really just the house under which our custom resources will exist. So let's start our, I guess, two parts here. First, there's nothing up my sleeve. Kubectl get pods. No pods. Up. I'm going to... Oh, I'm in the wrong directory. Go source, GitHub, Doug, Asterisk Operator, and start the operator. It'll take a second to boot. That's an ignorable error for now. And it's not doing anything yet. It's just sitting there. It's in the observe phase. So what I'm going to do is let's send out source, go source. I'm about to create this custom resource under that asterisk voip.example.com. And what we've got here that is really the most important for now is this size field. So this is what we're going to analyze when the operator sees this go. So I'm going to say kubectl create from this file, and we're going to see this is about to kick off here as soon as it notices it. We'll go back to this in a sec, but let's see what has happened, and then I'll explain what that did. So kubectl get pods, we're going to see that previously there were no pods. Now there are 2 to the size that we specified here. Also, if we get the custom resources, we can see that there is this new example asterisk, which was from the size equals 2. And also, something else is this is created as a deployment. And a deployment really is a way to express to Kubernetes that I want some number of copies of this particular set of pods. So basically what it says is, okay, hey, I'm going to create a replica set, and I am going to control that replica set. So in this case, it's a replica set of 2, and that results in 2 pods. So let's take a little bit of a look at the output from the operator. So essentially what it does is it starts up and it goes into a wait state looking for all of those asterisk instances. So once it finds them, then it goes through and cycles through each of them, and it says, okay, I've got this asterisk pod, and I'm going to create a trunk to this other asterisk pod. It knows its IP address, so it talked to the Kubernetes API to say, okay, that pod is ready. What's its IP address? And it will use that information in order to create those trunks. So also, some of this output probably came out asynchronously, but something that was like a little bit of a trickier part when I made this was waiting for things to happen. So kind of everything all happens at once, and then it goes through a number of phases. So I'm saying, hey, this pod has come up, but it has not finished booting asterisk, for example. It hasn't been assigned an IP address yet, so I have to kind of go into a wait loop and say, hey, is there an IP address yet? Okay, good, there is. And then I'm going to start trying to push stuff to Sorcery, and basically I look for a good HTTP response from it, and then I say, okay, you're good to go to do this. So 2 asterisk instances, and we have a SIP trunk created to each. So let's go ahead and log into one of those. So I can say kube control exec interactively with a TTY, this particular instance, and I'll do asterisk RBBV. And I'm going to say pj sip show AORs. And I've got 1 here. So I'm currently on this instance, and my SIP trunk is to a different instance. And I can go ahead and generate a call to it. So let's channel originate pj sip 333 at this application wait 2. And really, all that we're really looking for in this particular case is this line right here. The other end was capable of answering the call. That's really what we cared about. So now, let's go ahead and we'll modify this CRD. Let's make it 4. I've tried this with as much as 33, and that's something like 1,056 trunks. And it took a while, but it worked. I'm not going to do it now because it takes too long. And I was sort of disappointed that it took a while, but then I'm like, if I had to create this many myself, it would have taken a lot longer. So kube control, apply, file, deploy my CRD. And then let's take a look at this terminal output here. And it's found all of them, and it's going to create a bunch of trunks. And I believe that it has completed. So let's exec back into the same pod, pjship show address of record. And now, since there are 4 instances, we have SIP trunks to the other 2. And I can go channel originate pj sip at this host application wait to, and it answered. And just to show that they're all there, go ahead and originate one more. This guy. And it answered. So I've got connectivity from this pod to the other 3 pods. So we've got the ability to grow and shrink this asterisk cluster and create trunks between them all. All right, let's go back to the presentation. Thank you, Matt. All right. So you can do this yourself. I recommend the tinyurl.com/asterisk operator because that QR code is actually a Rickroll. So if you actually wanted to use it, you would use this one. Feel free to run through this article. It's essentially, it goes through a few things. So it gives you the ability to run everything that I ran right there. But most importantly, it gives you access to creating your own development environment, which in part I learned how to do from the Operator-SDK documentation. But I detailed it out a bit more so you can kind of go step by step and install the stuff. So certain things it makes an assumption about, like that you know how to install Golang and set your Go path and stuff like that. And I tried to write the article with no assumptions like that so that you could just get up and start poking at it. So there's a number of lessons that I've learned compared to what we were able to do last year with just VNF asterisk. So this is inspired by what we did with VNF asterisk, but something that I had to do with VNF asterisk itself was to create my own service discovery scheme. So I used etcd, and I essentially had this concept of this announcer, which was a initialization pod or container that started up, or maybe I did it with an entry point script, it doesn't matter. The gist is, when those asterisk pods started, they would go and figure out their own IP address, and then they would insert it into etcd, and then I would have the controller pick up the IP addresses from etcd. And that's a lot more overhead in terms of the tooling that I need, the logic that I've got to add to these guys. I was maintaining my own etcd cluster in order to do it. And when I started to write this, I'm like, wow, this is a lot nicer that I don't need to worry about any of that, since I can just ask the Kubernetes API about, hey, what's going on with these asterisk instances? Like, can't I just figure it out?
Kubernetes APIs, because it already knows all that info?
Yeah, that was a lot better. And so I really, last year, wanted to do something that was more like this, like automatically create the SIP trunks between everything. And last year, I basically had it so you had to click a button in a UI to say, I wanted to connect asterisk A to asterisk B. And in part, that was appropriate for the demo that we did because we kind of wanted to show how the controller worked. But I thought that it would be way more fun to like have the cluster dynamically attached. So I was really pleased with that. On the con side, and I guess I could say this directly in comparison to using something like the Ansible Playbook bundle, is all of this is written with Golang. And I love Golang. If you haven't picked it up, I'd give it a try. If you have any sort of C background, you're going to pick it up and you're going to be extremely pleased with it. But even if you come from kind of a like more of a scripting language background, I think that you'll find that it's actually pretty joyous to program in. However, it is still a strongly typed language, and it takes some planning in order to write an application. It's not like starting a Perl script and then just banging anything you want at it. It's more difficult to make a prototype. So that I thought was a downside, even if you could make the argument that, hey, for the longer life cycle of the application itself, it may be more maintainable in the long run than a Perl script that gets too big, and we've all seen how bad that can be. So you might ask yourself, should I make my own operator? And I would have to give this a firm maybe. Sometimes it totally makes sense. If you're already integrating with the Kubernetes API, this is probably a nice way to formalize that kind of interaction. So you'd be using the CRTs. It's kind of the decided upon lingua franca for operators. And if you use something like the Operator-SDK, you're using a tool set that is going to be maintained by a wider community that makes it for a lesser maintenance burden on your own code. Additionally, if you are creating a distribution of your software for somebody else to run, it allows you a way to give your opinion on how it should be run. And I would say at scale, then it even makes even more sense, because if you're going to be wasting your own operational life cycles on manually doing something to your platform or someone else's platform, it's even better if you can just directly automate that. I guess also the last thing is I think that if you're going to be using something like Kubernetes, more and more you're going to see software that you want to run come packaged as an operator. So you might have something like Prometheus for monitoring analytics, all that good stuff. And it's a fairly big application, and you probably want the creator's opinion on how you should run it. And in fact, this is part of what got me to really fall in love with containers. Is when I first started using them, I really liked the opinions that I got when I looked at a Docker file from the maintainers of Nginx. I'm like, okay, these guys clearly have an opinion on how you should run this, and I'm really glad to get their opinion and use it directly or learn from it or otherwise. So I think that it's nice to have a little background on how these actually work if you're going to wind up using somebody else's operator. In the link that I gave, there's also a quick tutorial on Helm operators. So Helm is a package manager for Kubernetes, essentially. And it gives you a way to template your YAML files that you use to deploy things in Kubernetes, from your pods to your config maps to your services, all of that good stuff. And the Helm operator kind of gives you a lower barrier of entry to create an operator. And it does so by essentially packaging together a configurable operator for you along with your application. So it's possible that you may get just as much benefit out of something like the Helm operator, which takes you maybe 30 minutes to give it a run through and give it a try, as opposed to compiling your own Go application, which clearly is a lot more overhead when you've got to slang Go code. So here was my one idea was, let's make a dynamically scaling Asterisk cluster with and create trunks between them all. But I'm like, hey, what if I really was going to put this into production? Clearly this is more of a lab experiment that I've got here. But something that I encountered a lot and was like a painful thing for me when I was managing a large Asterisk cluster myself, which was a couple things. One of which was, hey, if I have some kind of upgrade or failure or something like that, and I've got to drain traffic off my platform and put it somewhere else, wouldn't it be pretty sweet if I could basically just throw in a custom resource that said, hey, here's all the instructions on how to do that, so that in theory I could just like build something in Minecraft while it does it, instead of like sitting there babying it. The reality is I probably would still be nervously watching it, waiting for it to explode, because that's what life in production is like. But another thing that I thought of was creating a canary release in a similar type of fashion. Like, could I have a custom resource that says, hey, I want to take N% of my traffic and I want to put it on my new software and I want to see what's happening. And then potentially I could give it my own operational opinion about what constitutes a failure or not. So this would be a pretty common thing for me when I was working, in the world of telephony, and my boss was a guy who came from the 1980s, and he was very, very strict about what constituted a failure or not. And he'd been in the telco world for a long time, and we would have like serious soaks. So we would like change just a very small thing. We'd put 1% of traffic on it, and then we would analyze the daylights out of it. And I definitely spent a long time with my nose in a spreadsheet looking at this stuff, graphing stuff out, going to meetings, explaining all of this. If I could have automated a little bit of that, it certainly would have made my life a whole lot better. So it gave me the idea, like, hey, could I make some kind of detection? Could I parse some logs? Could I look at some metrics in Prometheus, something like that, and then drop that instance? And it certainly would be way better if I could mitigate those type of failures before I got stuck in even more meetings explaining to VPs what happened and having them ask, how is this never going to happen again? And the answer is it's going to happen again, just in a different way. So that's basically what I've got on operators. I'm just going to pull up the article that I have here quickly, and let's see what other kind of information's in here that might be. So if you go to dougbtv.com, which is my blog, that's an even easier tiny URL. So let's take a look. So it runs through everything that you would need to spin it up. So you just take a CentOS 7 machine, any which way you want to spin that up in a VM on your local host, or maybe you already use Fedora and you can kind of change it. And then we do stuff like install Docker, which I'm sure most of you guys have done. We're going to install kubectl, which is the command line for Kubernetes. We're going to do a little bit of network setup. And then in this particular case, I spin up Minikube, and I typically would usually not recommend Minikube, but that's often because I tend to look at things from an architectural standpoint. So often when I want a Kubernetes, I want a Kubernetes cluster. So I'm like a little bit disappointed by having just a single node. But in the case of developing an operator, it's actually less convenient to have an entire cluster. So I semi-recommend Minikube for this particular setup. Show you how to make sure that it's actually working. I recommend installing Golang. Did I even talk about why you would use Go, Leif? Did I talk about that? No. So, okay, quick semi-backstory. So when I first started looking at operators, my manager said to me, he's like, okay, great, it's an application that manages other applications. Why would you write it in Go? Why don't you just use a bash script? And I think that he was just trying to get my goat a little bit. You know, we're developers, we're engineers, we're sysadmins. We like to use the cool stuff, so I like to use the Golang stuff. But the real answer is it's because the good tools for accessing the Kubernetes API, today, those are in Go. So you're going to be bringing in those Go packages to make those interfaces. So I would say generally right now, your choice is Golang. That's not to mean that you couldn't do it another way. You certainly could write your own abstraction layer and do this in Python. And I'm sure that as time goes on, we're going to see more and more tools for accessing the Kubernetes API from other languages. But for example, using the Operator-SDK, those are Go libraries. So, you know, a lot of that stuff was just already in Go. I install some tools for Go, and then I use the Operator-SDK itself. And something that the Operator-SDK does for us that I absolutely loved is it gives us a way to scaffold an application. So basically what I can say is Operator-SDK, make me a new application, and it's got a few example applications for you, and I chose to start from a memcached application, and I really was happy with creating an application this way because when I started, I had only a very minimal understanding of operators. I really started from a point of like reading a high-level blog article saying this is why operators are cool, and I'm like, that's not enough for me. I want to like pick apart an application, and that was great because it's like memcached. It's like not a whole lot to absorb. And it gave me a way to go, okay, hey, great, this works now. Let me throw some traces in here and see what this thing is actually doing. And then I changed it over to be asterisk, and then I built in the logic with like push config and all that stuff, which we essentially had a reference for from VNF asterisk. So if you get a chance, take a look at this article, give it a try. There's links to GitHub for this application. If you run into any problems, totally throw an issue on the GitHub repo, and I'll try to get you out of a bind, or otherwise I can improve it. So, all right, thank you for checking this out. Really appreciate it.